There are 4 formulas that we learned about that we use with acid-base calculations. So it's going to refer to these, and as we go through the notes, I'm going to be referred to them as formulas 1, 2, 3, and 4 when we try to decide which formula to use. So the first formula is written as square brackets. Remember, square brackets mean molarity. It's a concentration. So you interpret that as the concentration of a hydrogen ion when multiplied to the concentration of the hydroxide ion is equal to 1 times 10 to the negative 14. And technically this has a unit of molarity squared, but just remember, anytime you're solving for something in square brackets, it always means molarity. So if you're ever solving for the bracketed ion, it should have a concentration of molarity. Another thing that you need to be aware of with these formulas is that we use H plus for the hydrogen ion, but that's the same exact thing as what they call the hydronium ion, which is given the formula H3O plus, because really it's a shorthand version of the hydronium ion. Hydronium ion is hydrogen ion with a water attached to it. So if you notice, there are 3 total hydrogens here, 1 oxygen, and an overall positive charge. So H plus is the same as H3O plus if you ever see that. Just something to remember. The next formula has a lowercase p and a capital H. And formula 3 also has a lowercase p and it has an OH. Now remember, hydrogens come from acids, OHs, hydroxides, come from bases. The p's in this formula, the p is a mathematical function where the p always means negative log. So if you remember that, it's easy to remember these formulas. pH literally means negative log of the hydrogen ion concentration. pOH literally means negative log of the hydroxide ion concentration. The final formula that we need to memorize relates pH to the pOH. So this formula says that the pH, when added to the pOH, always equals 14. Now technically this is unlimited sig figs. You don't have to write all these zeros, but they have unlimited decimal places because it's part of the formula. So let's look at some calculations. These are straight from your notes. The first problem says hydrogen ion concentration is 6.5 times 10 to the negative 2 on the pH, and then tell if it's an acid or a base. Now remember, you must use the pH to determine acidity or basicity. So always make sure you're referencing back to your pH. So we have a formula that has both of these in it, and it's formula number 2. pH equals negative log of H. So we're going to write our formula down because we always write our formula down. pH is negative log of the hydrogen ion concentration. Now let's plug in. We know the hydrogen ion concentration. That means pH is negative log of 6.5 times 10 to the negative 2. Now pH is a unitless number. Everybody plug this in on your calculator. You're using log base 10, so we're using the LOG, not the natural log. So when you plug it in, you're going to hit your negation sign first, negative, and then you're going to hit your log key. Okay, so that's what should pop up. And now you're going to plug in your concentration, 6.5. Remember, scientific notation is second comma, got your EE to pop up, and that's to the negative 2. And so we're going to round this to 2 sig figs. You should get 1.2 times, just 1.2. 1.2 is your answer on that one. So the pH is 1.2. 1.2. And pH does not have a unit. Okay? So the second part of the question said, is this an acid or a base? Well, since the pH is less than 7, this is an acid. Okay, that's because the pH is less than 7. Okay, pause the video and try number 2 on your own, and then once you have been given time, if you will then restart the video and check your answer. I'm going to go ahead and continue for time's sake, but please pause the video now and work on number 2. All right, so you should have got 8.1 for your pH, and so since the pH is greater than 7, this is a base. Let's look at example 3. We'll go ahead and go through this one for guided practice. They give you the hydroxide ion concentration and want you to find the pOH. So we're going to use formula number 3 to do that one because we have both of those symbols given in that formula. pOH is negative log of the hydroxide ion concentration. So just like with the other formula, we're going to plug it in the same way, but now we're plugging in for the hydroxide. 6.2 times 10 to the negative 4. So that means the pOH, you plug it in the same way, is 3.2. Okay, that's the pOH. Now always be aware, y'all, it's easy to get these mixed up, so always write them down. Otherwise, you will make a very careless mistake. Number 4 says, for example 3, so look back at our example for number 3. What is the pH? So we just found the pOH in example 3, so let's find the pH. So we're going to use formula number 4 for that because it relates the pH to the pOH. It tells us the pH plus the pOH always adds up to 14. Now, since we're solving for pH, I'm going to isolate my variable, which means I'm going to subtract the pOH over. So I'm going to go ahead and rearrange my formula. Now, you don't have to do this first before plugging in, but I like to rearrange my formula. So we're going to say 14 minus the pOH, which is 14 minus 3.2. Now, remember, this 14 has unlimited decimal places, so when you subtract, you're going to go with one decimal place because this one has one decimal place, this has unlimited. So when you subtract, you're going to end up getting 10.8 for your pH. Now, since this is the pH, it's the base. We just found the pH. Always make sure you're looking at the pH when you determine if it's an acid or a base. All right, let's look at example. I'm going to scoot on over to example 6. Because this example here, we're going to have to use 2 different formulas to work it out. Now, there's a couple of options here. Since they give us the H+, and we want to find the pOH, we could take the negative log of H+ first using formula 2. And then once we get the pH, we can subtract from 14 and get our pOH. But you could alternatively use formulas 1 and 3. I'm going to do it both ways just because I want you to see how to do it both ways. All right, so the first method is I'm going to first use pH equals negative log of H. So pH is negative log of 3.5 times 10 to the negative 6. Okay, I'll plug that in your calculator. All right, you should get 4.5. So now we've got the pH, and since we're wanting the pOH, I'm going to go ahead and kind of highlight my formulas so you can separate them out. So the next formula we're going to use is going to be the pH plus the pOH equals 14. So I'm going to plug into that. I'm going to plug in the pH. So pOH is equal to 14 minus the pH. So it's going to be 14 minus 4.5. And that's going to give us 8.5. Now keep in mind, we've just found the pOH. So if I were to ask you at this point, is this solution acidic or basic? What would you say? Now remember, you got to look at your pH. Don't let this be a tricky question. You got to look at your pH. Since the pH is less than 7, this is an acid. Don't get caught in the trick of looking at your final answer. If you found pOH, you can't use the pOH to determine acidity or basicity. You have to look at your pH. All right, that's the first method. Let's look at the second method, which would involve using formula number 1 and then formula number 3. So formula number 1 was H times OH concentration equals 1 times 10 to the negative 14. So that will be the very first formula we wrote down. So we're going to plug in, since we know hydrogen concentration, you're going to plug that in here for hydrogen there. So you're going to plug in 3.5 times 10 to the negative 6 times the hydroxide ion concentration equals 1 times 10 to the negative 14. Now to isolate our variable, we have to divide both sides by 3.5 times 10 to the negative 6. And that's going to give you hydroxide is equal to 2.9 times 10 to the negative 9 molar. And since we're solving for a bracketed ion, it's going to have a concentration